All right. Welcome to another SST weekly stream. So today we're going to be talking about function bundles. So function bundles are pretty important. Whether you're using SST or just using AWS Lambda directly, they're an important topic that you need to be aware of. It's one of the few more technical things that it is helpful to have a handle on. So in this video, we're going to talk about what they are, why they matter, how to think about it, how to optimize them. So yeah, let's get started. So to understand why we need to even care about function bundles, we need to understand a little bit about how AWS Lambda works. So I put together a very quick diagram. Let me switch over to it and pull it up. Sorry, getting used to all this setup. All right. Cool. So I drew this little diagram of how a Lambda function works. So everyone knows about cold starts and how cold starts are a thing. This diagram illustrates exactly how they are and when they happen. So this box here, let's think of it as our Lambda function. So when you deploy it, it's not really doing anything. It's just out there as an abstract concept. There's no specific resources coming in or anything. When a first request comes in to this function to send it something to ask it for an execution, it goes through these following steps. So first, it boots up. So it boots up a container, and this isn't like a Docker container. It's not like what you imagine with a Docker image. It's called a Firecracker container. It's effectively a really lightweight VM. It offers isolation and it can come up really fast. So I think it's at a baseline, it takes 300 milliseconds to come up. So when your function first gets invoked, it's going to need to boot this up regardless of what's going on in your function, what runtime you're using, et cetera. There's just the base thing in the execution environment. It needs to boot up to run your code. So once a container is booted up, it needs to download your code. So if you see here, I have a question mark here. So how long does this take? This really depends on the size of your code. Obviously, if you have a tiny bundle, it's going to be able to download it quickly. If you have, I think they increase the limit now, maybe to 10 gigabytes. I don't remember what the limit is, but it can be pretty high. So obviously, if it's really large, it's going to take a while to download. And this is coming from S3. So it's all internal AWS, but it still takes time to get it from S3 into the container that's running for your function. Once it has a code, it needs to initialize the code. So this basically is just starting up everything that you have in your bundle. So this is going to execute everything that's outside of your handler. So if you have any top level await statements that's fetching stuff from SSM, or for some reason you have a for loop at the top of a module that's just doing something complicated, that's going to block until the code's initialized. Once it's all initialized, it waits for a request. In this case, there's already a request waiting to be done. So it's going to handle the request right away. And then it's going to go back to waiting for a request. And it'll stay in this loop here. And I think until it doesn't receive a request for 15 minutes, and then it'll completely shut off. And the next time it gets a request, it needs to go through the whole cycle again. This is important to understand because when people are new to AWS and AWS Lambda more specifically, they think that a cold start happens every time you get a request. It's not exactly that. It's for the first request that comes in, and then from there, something is warmed up. So it's going to serve future requests. The next thing people think is, oh, if I just need it warmed up, let me just have something pinging this function and keeping one of these containers up. Let's say I ping it every 14 minutes so it never shuts down. Then there's always going to be something available for handler requests. That's true, but remember, you can really only keep up one container up at a time. So this container only handles one request at a time. It's going to wait for a request, it's going to handle it, and then it's going to start over. If another request comes in while it's handling the request, it needs to spin up another instance of your function to handle it. So function warmers don't really do anything. They'll keep maybe one instance of your function up, but as soon as there's two concurrent requests, that second request is going to experience a cold start. So there is something called provision concurrency. You can say, okay, at a baseline, let's always keep up 10 10 instances for this function because we want to make sure that we can handle a minimum set of traffic without any cold starts. But that's really an optimization. The thing to really focus on, because cold starts are always going to happen, no matter, even if you're using provision concurrency, if you have a spike in traffic, someone's going to experience a cold start. The focus should really be on how can we limit cold start. So if you look at this diagram, there's really only two places where we have variability. We can't change how long it takes to boot the container. That's AWS Firecracker. I'm sure they're improving it all the time, but it's out of our control. But we have these two areas: download the code and initialize the code. So we're not going to focus on how we can improve initializing the code. There's really usually not too much you can do there. You can maybe do some top level weight stuff in parallel, but in general, there's not too much to be gained there. So we can focus on the download code section. How can we make it so once the container is booted up, it's going to download, it's going to get through the step as fast as possible. And that's where function bundling comes in. How can we make our function as small as possible so that this download step happens really quickly? So yeah, let me pull up my notes to see what exactly we need to talk about. So function bundling or JavaScript bundling has been a thing for a while. It just really hasn't been a thing on the back end. And historically, we'd be deploying our code as long-running containers. Even before that, just like copying stuff onto a server that just stays up. So we didn't really have to care about how big our code was because we're only deploying it every once a day, maybe twice a day, and once it's deployed, it's just going to run forever, and the size doesn't really matter. But if you're working on the front end, function bundles, JavaScript bundles matter a lot, right? So that's transferring your front end code to a client, maybe on a slow internet connection, maybe on a slower device. You want to make sure that your code is as small as possible and anything extraneous has been stripped out of it. It's a deep topic, and it's been kind of nice not to have to worry about it on the back end, but unfortunately, now we're kind of exposed to that as well. The good thing is, because there's been such a focus on this on the front end, a lot of the great tooling that has optimized front-end JavaScript code can now be used to optimize back-end JavaScript code. The double-edged thing that comes with that is a lot of popular back-end libraries, even from huge projects that everyone knows about, they never really had to care about their bundle size or their code size, so they're not really packaged well to be used in Lambda. And I found, after a year or so of building exclusively with AWS Lambda, there's a lot of libraries that I'm used to using I had to find alternatives for. So far, I've been able to find really good alternatives for everything, so it hasn't really been a limiter, but it is something to be aware of. This is kind of new and the Node ecosystem hasn't really adapted to worrying about the size of backend code. So some of the things we're going to talk about is so this bundling concept. The tools we use to bundle with SST, we use ESBuild, ESM, which is the new module system that is going to apply to all of JavaScript, whether it's on front end or back end. But ESM has some properties that make it easier to bundle or to minimize your bundle sizes. Tree shaking, so this is dropping any code you're not using, and just generally talking about external dependencies. So before we jump into that, the one thing I want to also mention is layers. So a lot of people instinctively go to Lambda layers as a way to reduce this download code size. They don't actually help because these steps need to happen no matter what. If you extract some of your code into a layer, it's just going to be another part of the download code step. Your function still needs to download that layer. It might even slow things down if you extract it to a layer because you kind of mess with how efficiently things can be bundled. But so layers are really useful if you have, let's say, 100 functions all sharing the same code. It'll make it so you don't have to add deployment time. You don't have to like re-upload the same code over and over when you're deploying all 100 functions, but it's not going to speed up your cold starts. And that's another area that we see people get confused fairly often. So yeah, let's maybe start by looking at a really simple function that doesn't really do anything, and we'll look at how it gets bundled, and we'll kind of make it more complex from there and see how the bundle changes and how we debug it and analyze it. So let me switch to this. I'm going to have to increase my font size. Let's see. That looks good. All right, so this is a project that I bootstrapped earlier today, just using create SST. And in here, I had this really simple function where all it does is return hello. So there's no external dependencies. It's just this code here. And on the right here, let me see if I can make this bigger so you can see. Might not be able to see, but I will put in the description of this video later. I'll update it to have all the commands I'm using here. So what we're going to do is we're going to bundle this function. So the question is, what actually is bundling? So bundling is a process of taking an entry point. So in this case, it's this file, tracing all the references that this file has, all the files that it imports, all the files that those files import, pulling that all together into a single file and making it, compressing it into something that's a single file and as small as possible. So there's a really great tool called ESBuild. And if you're not aware, all SST uses ESBuild heavily to bundle your functions. ESBuild is a bundler written in Go, not in JavaScript. It's written in Go. And because it's written in a much faster language for the type of work it's doing, it can bundle things really fast. That's the reason we use it, because it's really helpful with the hot reload and things like that. So what we're going to do here is I'm going to call ESBuild directly instead of using it through SST, so we can examine some of the output that it's doing. So I have this really big command here. I'm actually going to paste this in my editor so we can actually look at what it's doing. So I'm calling it the ESBuild. I'm passing in minify, so this will minify it. So anything like the word handler, it'll like rewrite to like E or something. That's not a good example because that's public, so I don't think it'll actually do that. Looks like someone's got a question. If I'm already using SST, my functions are already being bundled through ESLint. Does this mean I have no extra work to do to get them optimized? I think you meant ESBuild, but yes, they are being bundled. But as we go through this call, you're going to see how we're doing a lot for you to bundle efficiently. But there's some things that can happen that make your bundle a lot larger, and I'm going to show you some debugging steps to figure out how to make that smaller. Typically, if you're seeing cold starts that are above a second, you probably have something going on that's not intentional. And that's when you know you can have to look into your bundle and see what's going on. We definitely want to make these analysis steps a little less manual and build them into SST. It's not clear right now what that should be. I myself am just getting better at doing this. So once we have something that's repeatable, I think we'll try to build it into SST. Like maybe in the console, it can show you, hey, like this function's big. Like, did you mean to, include all this in there? So we'll take a look at this this command. So this is a command. This is effectively what SST is calling under the hood. It's a little bit more complicated than this, but roughly this is what's going on. So we're calling ESBuild. We're going to minify. We're passing in bundle. So what this flag does is it says the output needs to be a single file, so consolidate everything into a single file. The format is ESM, so I mentioned earlier. It's a modern module system. Recommend using it. All the new default create SST templates do use it by default. Target ES index, which means it's outputting ESM as well. Platform node, again, we're building for node. And this is the function we're going to bundle. So let me simplify it. Here, let me change this to this hello.ts file, specify an output file, and I'm turning on this analyze flag. So this analyze flag is going to be really useful, and I'll show you what it does. And I'm piping out the standard error to a file so we can look at it easier. So if I run this, let me copy this properly. Okay, so that bundled, and we'll take a look at the output now. That is not right. Let me see what happened here. Oh, I bundled the wrong thing. Okay, hello. Let me see, this should be hello TS. All right. Okay. So now if we take a look, this is the bundled result. So ESBuild rewrites it a little bit. This is a really simple function, so the rewriting looks trivial, but there is a reason for this. With the function this small, the end result is actually bigger than the input, but again, it's just a contrived example. And we can take a look at the analyze output. which breaks down what exactly is going on. So you can see the output is 49 bytes, extremely small. Took 4 milliseconds to bundle. This is the output, and this is what the source files are made out of. So pretty straightforward. Nothing crazy for a simple file like this. So now let's do something a little bit more complicated. Let's reference another file. So let's just make a new one, say sample ts. I'm going to export who equals hello. And in this file, we're going to import it. What do I call this? For sample, import it, and return this. All right, let's run our bundler again and take a look. Why didn't did I not save it? Let me see what's going on here. Flow.ts. Why isn't this working? Did I not? Oh, there we go. I didn't save this file before. Okay. So now if we look at the output, you can see it. Yeah, output larger than the source. Yeah, that happens. It's interesting to know that can happen. I don't think it happens in practice, but it's funny. So anyway, let's take a look at this. So you can see that ESBuild did something pretty clever here. It realized that, okay, this is the only thing that's being referenced from that file. So let's just inline it with everything else. And this, and it kind of and you can see how it turns it all into one file. I'm actually going to turn off minification. It'll be a little bit easier to understand. This is with the minification off. You can see it combined what was in 2 separate files into a single file. So it's the final size is going to be smaller than having 2 full files, especially as your files get bigger and more complicated. And so this is an example of how that works. So I'm looking at another comment. How would you recommend including source maps in the function bundle? I see where it makes the bundle much bigger, but you get info when it comes to debugging. So I'm going to cover source maps at the very end. I myself am a little bit split on them, so I'll kind of talk about how I'm thinking about them currently, and you can decide whether it makes sense for you to use it or not. So anyway, going back to this. So now we have a slightly more complicated situation. We have 2 files still getting bundled into a single file. But so far, everything looks good. If we look at, I don't know why the node modules are getting picked up here. If you look at the analyze here, you can see that, okay, it's breaking down output.js into 2 separate, breaking output.js into all the inputs, LOTS, and then sample TS there. All right, so let's make this a little more complicated now. Let's do something that's pretty common that I myself was doing for a while and didn't realize that there was a problem with it. And I think a lot of people do this. So it's common to create index files. So you might have an index file for your library that re-exports other things. So we have this sample module that I just created. We're going to re-export stuff from there. Let's actually create sample 2 as well. So and let's call this bar. And let's have this index file export both. And then in our function, we don't need to specify the full path. We can, wait, I'm going to have to specify index there, but it's because my aliases are set up differently. But let's just import bar and ignore foo. Okay, and let's run this bundling again. Now, if we take a look at our bundle, off minification again. So you can see that it's only importing the very specific thing that you imported from index. So far, it looks like this is looking good. You can have index files. You can export different things from there. You can import from the index file, ES buildable tree shakeout, whatever it's not using. This is the tree shaking concept that I referred to earlier. It'll only reference the files or the variables you're actually using. Let's make this a little more complex. Let's turn these and let's actually export another function from here. So let's call this the foo function. And let's also have the bar function. All right, let's look at our hello again. Okay. We bundled it, put our output. All right, it's continuing to work. So you have all these extra stuff that you're not using, but it doesn't get included in your bundle. So let's have, let's actually just log it to make it included. Look at our output. You can see now the function is included and in line there. And if we look at our analyze, you're getting a full trace of everything that is actually included. All right, cool. So now let's keep going. Let's make this a little more complicated. Let's actually bundle the built-in GraphQL function that we bootstrapped everything with. So this is this is from our new stack that we're going to be releasing soon. There's a GraphQL function that provides the GraphQL handler. So let's see what it looks like when we bundle that. GraphQL TS. All right, so let's take a look at our analyze. We can see this is huge, right? Our GraphQL handler is 16.7 megabytes. This is really big. I think you don't really want to exceed more than a couple megabytes. Again, it depends on what you're doing, but when you start to get to this size, especially if it's not intentional, it's probably not on purpose. So let's take a look at what's going on here. So this is where this analyze command comes in handy. You get to really see the breakdown of everything that is being bundled. And I'm going to try to get this all fit on the screen here. Okay. So hopefully this is visible. All right. So let's start. So we have the output. The output is almost 17 megabytes, way too big. And let's take a look at what's actually being included. This analyze command sorts it by size. So typically you just want to pay attention to the stuff at the top and work your way down. So let's take a look at what's going on here. So we're seeing a bunch of AWS SDK things being bundled in here. Looks like there's an EC2 client. Looks like there's a SageMaker client. Looks like there's an IoT client. This is already feeling a little odd because I don't use any of this stuff in the GraphQL function. It really looks like every single thing in AWS SDK is being bundled. So that's what's strange. So you can kind of spot, okay, this shouldn't be included. Now the question is, why is it being included? So if you follow this trace all the way down, you can start to get out of the node module section and get into your actual code. So we can see in API core SQL.ts, somehow that's triggering importing all this weird stuff. So let's actually go take a look at what's going on in that file. Okay, cool. So we can see we're importing RDS data service directly from AWS SDK. So this is a quick gotcha that happens usually to everyone because there's a lot of code samples that import directly from AWS SDK. Do not import directly from AWS SDK. With the way that it's bundled, it'll include every single thing in the AWS SDK, whether you're using it or not. What you want to do is write clients and there's usually a file named exactly what you're looking for. If you rewrite it like that, it's going to import something a lot more granular and a lot more specific. So if we follow this, it's just going to import this RDS data service class, and it'll follow the imports from there. And let's rebundle this and take a look at analyze now. So yes, AWS SDK is the fat lady singing. There's a lot of gotchas with it. This is just one of them. And you'll kind of see as you do this on your own code base, you're going to find probably a few weird things. Devin mentions this happens with Material UI. Yeah, in general, this bundling thing is confusing. Even as someone that builds a tool that does bundling for you, I get confused by it all the time. You kind of need to go through this process with your own code base a few times to really get what's going on. So anyway, now that we imported it more specifically, you can see our bundle size dropped to 1.5 megabytes. That's a huge improvement. Was that like 16 times less or something? And we've fixed that issue with everything being bundled. So now if we look through the biggest files, you'll see that it's not AWS SDK related, at least at first. We have this GraphQL tools file, pretty big, 77 kilobytes. We unfortunately need to use that right now. I am looking for ways to make this something we don't use. And then we do have some AWS SDK code in there. There is some common code that you're going to import no matter what client you're using. I will say this one thing about the AWS SDK libraries. They've gotten a lot better, but I do wish they would focus a little bit more on this bundling issue. A lot of us are deploying to AWS Lambda now. These bundle sizes do matter. And you can see, ultimately, the SDK libraries are simple, just HTTP clients. The reason they're so big is because a lot of these clients are code generated. It makes it easier for the AWS team to maintain. But we are kind of incurring that cost with some pretty large files that get included in our bundles. You can see there's all this common code, 53 kilobytes up there. There's another XML to JS thing here. It's another 44 kilobytes. You can see like the top, like this, of the top 5, 3 of them are AWS SDK related. I think this is an area that AWS definitely can improve. Historically, they were including AWS SDK into the runtime environment by default, so you don't have to actually bundle these. Like, they would just kind of be magically available, which helped a lot. Unfortunately, with the shift to ESM, this no longer works. They're also not bundling in the V3 libraries yet. I poked around in the GitHub issues. I think I saw some mention of, with Node 18, they're targeting bundling the V3 AWS SDK into the runtime itself. So if you look at my diagram from before, where you have the boot up container and then the download code, when I say they're going to bundle into the runtime, it's going to be part of the boot up container phase. So we can actually benefit from that if they do that. So once they bundle ESM v3, all of our functions are going to start booting up faster. So if we keep going through this, the rest of this is all GraphQL related. Because this is you can think of this as a mono function. It's a single GraphQL entry point that does all of your GraphQL stuff. It's going to be a little bit bigger than a simple single purpose REST endpoint function. So yes, there are some other sizable GraphQL things in here, but not really too much to worry about. Our function bundle is still it's still below 2 megabytes, pretty good. Just for a quick demo, so we can do this thing with ES build where we can mark certain packages as external. So we can kind of pretend like, what would this bundle look like if we didn't have to bundle AWS SDK? So if I run that, you can see now this is now less than a megabyte without any of the AWS SDK stuff in there. So yeah, it kind of demonstrates how much smaller it could be. This is also a useful tool when you're exploring your own code. If you want to just look to see what would happen if you eliminated certain dependencies, or if they were bundled better, you can just add additional external flags here, which will help with just you kind of add it, run the command again, look to see what the analyze looks like, and kind of see how things can play out. All right, cool. So the next thing, I thought it would be interesting to try a public uh, library, just like a standard popular library that people use, and just dropping it in just like you normally do, and see how it affects the bundle sizes. So because we're talking about GraphQL, a lot of people are using Apollo inside of Lambda. There's an Apollo Lambda library that helps you do that. So I thought we could create a function that is using that and see what the bundle looks like. I don't know how to do this off the top of my head, so I'm going to look this up. I have to add this Apollo server in there. Let's add this to our backend. Right, we already have GraphQL installed, and let's use this simple sample code they have. Closed my editor. Let's bring it back up. Send this one away. All right. Sorry, I'm going to make this bigger again. Okay. Go back to this. Paste in that code. Let's rewrite this to use import statements. Cool. See, server, create a handler. Let's do export const handler equals. Okay. All right, so this looks good. Now let's try to bundle it like we bundled the previous stuff before. And all right, let's see how this what out to. Wrong directory. Back one. All right. Let's write this to the file. Oh, sorry. Let me not mark AWS SDK as external. All right. So let's see. This looks too similar to the previous one. Did I not save this? This updating. Okay, I have this function. The output looks like the really crazy stuff. This looks like it's still bundling the old thing. Let me see what's going on here. Oh, sorry, I'm bundling the wrong function. There we go. LOTS. All right, this should have worked now. Okay, yeah, it worked. So now let's take a look at, again, a common library. A lot of people are using this Apollo. Our docs even have a GraphQL construct that works specifically with this Apollo server. So you can see baseline's 3.4 megabytes. Not terrible, but once you get to this range, you're going to see closer to a 1 second cold start time. Below kind of where we were at before, like 1.5 megabytes. In my testing, I found that to be closer to 500 milliseconds. Depending on use case, what's acceptable to you may vary. I feel pretty comfortable in the 500 millisecond range. Anything higher, I feel like the user starts to notice, which isn't a great experience. So let's take a look to see why Apollo is 3.4 megabytes. So if we look here, there's some interesting stuff in here. Let's actually trace this all the way down. We have this initial thing called mapping table.json. So this is a whole JSON file, pretty big one, 200, almost 300 kilobytes that's included in here. And I don't know what it is. I don't know what it does, but if we trace it, it looks like it's a dependency of node fetch. So it looks like node fetch is now being included in this. I think fetch is now natively available in Node 18 and above. So I think anywhere you see Node fetch can go away soon. As of now, it looks like it's still required. And we start to see something that looks a little more familiar. There's Apollo server or Apollo server environment, whatever that is. Apollo server core, then Apollo server Lambda, which is the thing that we implemented. So we've got one thing that's already 286 kilobytes. We can look into some more stuff. So now we have another JSON file. It looks like this is a database of a bunch of MIME types. Why does Apollo need that? The reason it needs that, if you trace this, is because Apollo server actually uses Express under the hood, Apollo server Express. So the reason it does this is because the Apollo team needs to maintain adapters for all kinds of deployment environments. AWS Lambda is just one of them. You might be deploying to an Express environment, various container environments, all sorts of places. So what they've chosen to do is to build everything off of an Express server. And no matter what environment you're using, it's going to transform the input into a Express request. So when the input comes into the Lambda function, it actually gets transformed to an Express request first, gets routed through Express, and then actually triggers the Apollo code. So again, this is a nice example of what I mean by people building backend libraries never really thought too hard or had to think too hard about bundle sizes. This is a really elegant solution for them. They build one adapter and kind of minimally smaller adapters for different environments, and they can support all sorts of things. But there's a big trade-off here. We're shipping a whole Express server that we're routing your Lambda event through, and that's going to be slower at runtime, of course, but it's also going to affect your cold starts because now it's including all this other stuff that you don't need. So if we keep going through this, there's a bunch of other stuff here. It looks like there's Apollo's really great reporting feature, but it is pretty big. The protobuf's there. This icon v light. Again, I don't know what these things are, but this one I've seen bundled by accident, like in a bunch of places. It might be a result of node fetch. So you can see there's a lot here. So the question is, how much is Apollo specifically adding to this? And this is where that external flag that I showed you earlier comes in handy. So if we look at our function, and the only thing we're importing is this one Apollo server Lambda package, but it's including all this other stuff. We can run esbuild with that external flag and pretend like this Apollo server Lambda is not part of it. So if I run this, now let's take a look at analyze. So it was at 3.4 megabytes before. Now look at it, it's at 350 bytes. So just the Apollo portion of it was accounting for, like 99% of, I don't know what the actual number is, but a huge percentage of all the code. And if we are a little bit more granular, let's say like they fixed that node fetch issue. So like node fetch is no longer a part of it. 2.5 megabytes. So that's a megabyte drop down already. And then we kind of start to unwind this. Like, what if they took out the Express thing they're doing? Kernel Apollo server Express. That doesn't really do too much. Oh, well, it's because the actual Express server is still being imported. Let's get rid of that one too. Now down to 1.4 megabytes. So now we're kind of back to the range that we saw earlier. And again, what we saw earlier included a bunch of AWS SDK stuff, Kaisley, a bunch of other things to use in practice. But you can see how now we're getting to a more reasonable range. Looks like even parts of Lodash are bundled in here. So this is a process I went through when I was working on our next generation of GraphQL tooling. I initially started with Apollo, really popular, a lot of things plug into it, but the reality is it wasn't architected from day one to be very light and work in environments where cold starts matter. So that's when I started to dig deeper and say, okay, how can we get a lot of this functionality without all this heavy stuff? And that's actually what if you use Create SST and start a GraphQL project, that's what our handler does. It's a much more optimized version of most of everything that Apollo does. There's some features that it's missing, but you can choose to add those in later if you want. We find that most people never really need to add those in. Not to pick on Apollo specifically, this is just a reality of the history of Node.js. It was meant for long-running servers. Now we're using it in these short-lived environments and a lot of libraries. Again, you'll be surprised the popular the libraries doesn't necessarily translate to them having had the time or the incentive to focus on some of these things. So it's important to do your own profiling. Like I said, we can bundle all this stuff automatically for you, but the resulting bundle we can't guarantee is efficient. It all depends on what dependencies that you're using, and how they interact with each other. So highly recommend using esbuild, running these commands to run analysis on your own functions, and see what's going on. Like I said, this is a crazy command to run on your own. We should probably add an SST command that's like SST function analyze or something that does all this for you. The configuration you have in your SC code also affects this, so it can also take that into account and kind of give you some information on or some hints on what to do. We haven't done that yet, but I think it is something that we should do. So yeah, I think that's everything on function bundling. I know we had a question on source map, so let me quickly jump into that. So one of the big problems with bundling is once you bundle, and especially if you minify, let's add the minify in here. And if you take a look at your output code, it's of course a bunch of nonsense. And who cares? This is just running in the Lambda environment. This doesn't matter. Where it does matter is when you have errors and your stack traces look like garbage. So the issue is once it's bundled, even if you're not using minification, it's combining a bunch of separate files into a single file. You're going to lose some context around what's happening. So that's why people want to ship source maps with their functions. And this makes sense. If you ship a source map with your function, Node will remap your stack trace to the original locations where things happen. So you'll get even if you're shipping something that looks crazy like this, you'll get a clean source map or clean stack trace and you're able to find what's going on. The issue is all the work you did in bundling and making your bundle small, you're just going to break even on the source map because now you're shipping a potentially big source map. So I don't remember the command off the top of my head. I think it's map. Is it just source map? Let's see. I have to look it up. Rising. Okay, yeah, it was just source map. So if you look at the source, so we minified, assuming we somehow got rid of these dependencies, we got this down to 666 kilobytes. Hail Satan. And then we have the source map, which is 2.2 megabytes. So it just kind of undid all of our work. So this is a big trade-off. Like, why bother doing all the bundling if the source maps are still going to be heavy? It's not like 100% for a loss. It's less code for Node to process while starting, but it's like very trivial. So this is a cost with source maps. Like you are shipping a bigger bundle in the end, and maybe it does slow down your cold start significantly. It does, like I said, you need to test it on your own, compare what the cold starts look like with or without a source map, and decide whether it's worth it for you. But here's some alternatives to consider. So you don't need to ship the source map with your function if you're using an external tool for error handling. So a really popular one is Sentry. So you can ship your source map, your functions bundled and messy and minified, as long as you ship you can ship your function code messy and minified, as long as you ship your source maps to Sentry. And then Sentry will do the work when an error happens to rewrite your stack trace to look correct. And most error handling tools support this. This is another area we want to build into SST. We can ship your source map somewhere, and with our, with SST console, when you're looking at the logs, and we're going to build in error reporting and exception handling in there as well. Let's say we email you when an error happens, we can rewrite the source map there, so you don't have to make that trade-off. You can ship small functions, and we'll rewrite the stack trace just in time when you're looking at it. So there are solutions for this. Today it is a little more involved, but it's an exciting area for us to potentially improve. Cool. So I think that's everything I wanted to get through. Let me take a look at my notes to make sure. ESM, tree shaking, external dependencies. Yeah, cool. So hopefully that was helpful, and you all use some of the techniques in here to analyze your own functions. I haven't been paying attention to the comments, so let me take a few minutes to look through this and see if there's any questions that I need to answer. AWS SDK is manageable. AWS CDK lib is currently a nightmare. Yeah, AWS CDK lib is huge. Thankfully, it doesn't leave your machine, but it is giant, and I can probably even show you how big it is. Yeah, right here. So AWS CDK lib, 250 megabytes, way bigger than anything else that's in Node modules. Well, AWS CDK is close. So AWS is very good at shipping these huge bundles. And again, it's because of this code generation approach that they have. Again, makes it easier for them to maintain libraries in multiple languages. It's totally understandable, but there's a cost that bubbles down. And this is a JSII, which I'm not super familiar with, but I do know I believe that's what it's a framework they use to generate CDK code that works across Python, Node, and I believe .NET. I'm not sure if it's .NET or Java. Maybe .NET and Java. Yeah. Let me take a look. Trouble with that is you have no control over. Yeah. So the one downside I was saying earlier, you can if AWS bundles in V3 or V2 or whatever they bundle in, and you just use a bundled version into the runtime, and you just use a bundled version. You don't control the version, so that can be risky because you're basically automatically getting upgrades you're not opting into whenever you deploy. That said, AWS is very good about building stuff that is backwards compatible and not breaking things, mostly because most of it's code-gen. So yeah, it is something you have to choose whether you want to be exposed to that risk or not. And Ross seems like he's mentioning there he does remember a time where something changed and people had issues that happened. So okay, maybe it does happen. So again, just a risk you need to consider. IconV handles text encoding. That's helpful to know. Still don't really know what that means, but I'm assuming that's like the UTF-8 and the ASCII stuff. Should be a paid session. Thank you. It is a paid session. I get paid by SST to do this. So, how to debug bundle cold start doc? Yeah, I think we can wrap a lot of the advice in here into a document that helps you figure this out. Yeah, so Ross caught something that that was kind of weird. So earlier when I was showing the index exports, I actually wanted to show that index exports don't work well and they like bundle everything, even if you're just using one thing in it. But I couldn't actually recreate it. There is an issue with them though. If you look at ESBuild has an issue with this where tree shaking doesn't work well when you're re-exporting stuff. So if you have a bunch of files and you re-export them all from an index file and you import them from that index file, I think it has to do with this side effects concept. I need to look more into it. I tried to demo it here and it didn't work, so I just pretended like that's what I wanted to show and I just went along with it. But yeah, I need to narrow down what situations that doesn't actually work in. There's maybe I can kind of demonstrate what I mean by side effects real quick. So okay, so let's take the sample file. Let's just delete everything from it, and then let's take our simple hello. Delete all this. So let's import this core sample file. So the sample file is on the right. So let's say this sample file does nothing but console log hello. So this is kind of one of the challenges that ESBuild has. So if I write this, import SSD core sample 2, and I know this handler, ESBuild could look at this and say, hey, we're not actually importing anything from this file. Let's just drop this import. Let's not even reference it. Let's But the issue is, at runtime, you'll never see this console log print. So that's one of the challenges ES build has. It can't really tell if, and let's use like a maybe more realistic example. So if we export, so in this case, it can say, okay, it's importing foo, but nothing else is being imported. So let's just lift just the foo and bundle it in and drop everything else. But again, this console log will never be printed. So this is what side effect is. If you have code that needs to run just because the module is imported, effectively the whole module needs to be imported. So ES build does struggle a little bit with that. And I think there's something that combines with this and the re-exporting that causes certain bundle sizes to be bigger than you expect. Again, after this stream, I'm realizing I need to go look into that more. One of the things I've been thinking about is if you look at Vite, so if you're not familiar with it, Vite is a build tool for the front end. It doesn't actually do any bundling on its own. It uses two things. So during local development, which you can think of as SSC start, you're constantly changing stuff. You need quick rebuilds. You want stuff to load as fast as possible. It uses ES build to bundle because having the absolute smallest bundle size doesn't matter in development. The speed of bundling is what matters. But when you go to deploy it for production, it'll use rollup instead. And rollup is a bundler written in JavaScript. It's a lot slower, so you can't really use it for live development, but it's very good at tree shaking and very, very good at getting you an absolutely small bundle size. So there might be a future where we do something similar, where we might even just use Vite directly. And I think we've had some suggestions on that before, where we use ES builds for local development, but we use rollup for production builds. The thing that's tricky with this is when you use two different tools for two different environments, there's a possibility that something that works in local development does not work in production. That's something we really care about, that you can rely on that. So that's why we haven't jumped on it and done it right away. I think if we're able to build off of Vite, potentially that, we're part of a bigger community that's trying to have both these tools output the same thing. But again, another area for us to explore. Cool. Let me keep going down the questions. Enable source maps conditionally in a staging environment. Yeah, that's a good idea. We have a new source maps option in SST. So you can say, realistically, I think you're going to specify it as a default. So you can say bundle source map, like was suggested, app stage equals staging, something like that. And you can have source maps just in staging or just in local development, or just in development environments and not production. Something like Sentry would add up to cold start and add latency to every request. So if you guys see my message from maybe 2 weeks ago, I did a lot of exploring with Sentry. If you use a Sentry layer, the Sentry layer is huge. They were accidentally shipping a bunch of stuff with it, and it was really hitting my cold starts. I think my cold starts went from 500 milliseconds to like over 2 seconds just by including the Sentry layer. But if you drop the layer and just import the library and let it get bundled along with everything else, it actually doesn't affect your cold starts. And you also have to disable tracing, because tracing sends a request at the end of every time your function is invoked. It like packages the trace and sends it, and that slows things down. So if you use it just for error handling, you can kind of do it at almost no cost, but it's definitely not the default behavior you're going to get if you just follow their recommendation. So if you're using Sentry and you're seeing some issues, message me and I'll kind of help you work through that. I like big bundles and I cannot lie. Nice. Any word on when the ideal stack will be ready? I know it's a big undertaking, just excited. I'm excited too. So we finally set a tentative date for ourselves internally this week. We are pretty much at a code freeze on at least the first version of it. So if you want to like poke around, it's probably not going to change too much. All of our effort now is going into writing a learn guide. We're kind of overhauling how we're thinking about the SST documentation process, and we're centering it around this stack. So we're walking you through, setting up your database, doing some domain-driven design stuff, doing GraphQL stuff, and I just started working on it today. We're working on it the next 1 to 2 weeks is our timeline, and we're going to do an event that we'll announce more details on probably next week to kick that off. And we have some interesting ideas for the event. We're going to be interviewing some of the authors of some of the libraries that we're using. So stay tuned, and we'll have more about that soon. Looks like Jay said that, right? And talks about it. I had index exports issue with slow Jest tests and a huge React app. I stopped using them because of that, so I relate. So hot take, but I'm going to say it. Stop using Jest. It is really, really broken for a lot of situations, especially with the shift to ESM and like even just using TypeScript in general. It is hard to configure. Behaves really weirdly sometimes, like stuff that works at runtime for your normal code doesn't work under Jest tests. And just really slow. I don't know if I said that already, but it's worth saying again. It is extremely slow. The new ideal stack uses vtest by default. It's more or less a drop-in replacement for Jest. If you're used to writing Jest tests, you can continue writing Jest tests the same way you've been writing them. It just changes the underlying system of how your code is built, bundled, and run for the tests. It is extremely fast compared to Jest, and literally everything works out of the box. And it's built on top of Vite. So the Vite ecosystem is blowing up. Vtest has been amazing alternative to Jest, which has been such a pain for us for the past couple of years. I also saw, I forget the name of the project now, but it's an alternative Storybook. So Storybook is built on top of Webpack, I think. I think they do have like a Vite version of it, but there's a new alternative to Storybook, which is another extremely slow tool that is built on top of Vite. So super excited about the Vite ecosystem. A lot of cool stuff happening there. All right. Let me see. In our case, useful experience. A side effect was happening within a module that was exported by an index. Oh, interesting. Yeah. Okay. So that might be related. Maybe the re-exports, if it somehow detects there's a side effect in there, it'll kind of include everything. I need to see, because I thought I didn't really write side effects code with side effects like that, but it might be that initializing any class inside of a module might be considered a side effect. Cool. Great talk. Really insightful. Thank you. All right. So I think that's everything from me for today. If you have any more questions, if you go and try some of this stuff out and get confused, of course, please message me. This is a skill that you're going to develop over time. It might be a little confusing at first, but like with everything else in serverless and maybe in tech in general, it's confusing at first, but within the end, pretty simple. All right. I'm going to hop off. Everyone have a good day.